Hey, physical science students, I'm going to go through some of the Lewis structures that I assigned this week. I'm going to do the even problems, and then that'll leave you with the odd ones to try on your own. So if you haven't attempted these, give them a shot. You can turn in what you've tried, and then make sure you're turning in your work because we only have 4 weeks left, and this is a pass incomplete. So even if you're not getting them 100% correct, if you don't turn them in, we don't have anything to grade. So again, try your best, stay positive. You can do this stuff, and if you can't do it, then you just got to do a little research online. There's plenty of videos on YouTube on how to draw Lewis structures, and many of these ones that we've asked you to try, you can just look them up, and they'll have some video tutorials on how to do them. So, anyways, let's get started. I'm going to do question number 2, which just says draw the Lewis structure of argon. So I look, argon is, if this was the periodic table, right? And it kind of looks something like this. Argon is kind of over in group 8. So this is group 8A. And so it has 8 valence electrons. So I just start and draw argon. I go 1, 2, 3, 4, 5, 6, 7, 8. And you can tell argon has a full octet. So the noble gases, the 8A gases, they have a full octet and are stable. So they don't really react or interact with many other atoms because of their electron structure. Number 4, I'm going to go with oxygen. Oxygen is just over here in group 6. So this is group 6A. Again, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so group 6 would be oxygen. So I just put oxygen with 1, 2, 3, 4, 5, 6. And you can tell oxygen is going to look for 2 electrons, so it'll form 2 covalent bonds with things, right? And so the structure of oxygen lends itself to 2 bonds because it has 2 spots, or it's looking for 2 electrons to complete its octet. Number 6, F2. So fluorine is in group 7. So I have 2 fluorine, so 7 plus 7 electrons. So I always start, when we start doing compounds which have more than one atom, you always start by laying them out next to each other, draw a line. That counts for 2 electrons, and then I can draw in 4, 6, 8, 10, 12, 14. I have all 14 valence electrons accounted for, and everything has a full octet. So there's no empty spaces around either of the F's. So I know that that one's correct. Okay, number 8, CS2. Carbon, right, is right next to, or it's in group 4. So 4 plus sulfur is in group 6, right below oxygen. So 4 plus 6 plus 6. Again, CS2 is made up of 3 atoms. So I have 1 carbon and 2 sulfurs for a total of 16 valence electrons. So I try and draw the structure symmetrically. So I put carbon as the central atom. And I do this. This is my process. So I fill in bonds. So that's 2, 4. Then I'll fill in the rest of the octet. There's 6, 8, 10, 12, 14, 16, 18, 20, which you can tell I don't have 20 electrons to work with, but I just drew in 20, so I need to fix things. So I'll go through and I'll erase maybe 2 lone pairs and draw in a double bond. And now if I count again, I'm down to 18, but I need to do that one more time. So I'll erase this lone pair and this lone pair and throw in another double bond. And so now if you add them up, there's 2, 4, 6, 8, 10, 12, 14, 16 electrons. And everything has a full octet. And again, by when I say that, I mean if you look around sulfur, there's a total of 2, 2, 4, keep erasing, 6, 8. Again, bonds count as 2. If you look around carbon, 2, 4, 6, 8. If you look around, let me erase those. If you look around sulfur, again, 2, 4, 6, 8. Right? And so you've got all 8 electrons accounted for everything. And so those are valid Lewis structures. Okay, and then last one I'm going to do question 10. Question 10 says NH3. So I can draw the structure first. N, H, H, H. H can never be a central atom. So here's 2, 4, 6. And I better add up my valence electrons. Nitrogen is in group 5. Hydrogen is in group 1. I have 3 of them. So I can multiply that times 3. So 5 plus 3, I have a total of 8. I've used up 6 of them in the bonds. So I only have 2 left. The only place left for them to go is around the nitrogen. So nitrogen has 1 lone pair. It has 3 bonds for a total of 8. And then those hydrogens, a reminder, they're happy because they're such a small atom. They're happy with just 2. They don't need a full octet. So all those hydrogens are happy. So hopefully this helps. Again, try the remaining problems. Turn in what you have. You turn them in by Friday. The teachers probably won't be looking at your stuff until the weekend, but we'll get grades updated and let us know if you have any questions. And hope you had a good week. Talk to you later.